Hi, my name is Sarah Billings, and I'm going to go over the problem 3D from our last test because this is the problem I had the most trouble with. So the problem states that a comet approaches the sun from far away but does not orbit or collide with the sun. And they want you to plot on this energy graph the kinetic energy, the potential energy, and the total energy. So what I went ahead and did here is I decided to make my own sketch of the situation. So here is the sun and the comet, and we're going to sketch in the trajectory. Alright, so here you can see the trajectory of the comet. It heads towards the sun, then loops around it and continues on its path. It does not collide or orbit. So we're going to solve this problem in a four-step manner. The first step is going to be to define our potential energy. So we know that in this situation the potential energy is a potential energy due to gravity. So the formula for this is negative g m of the sun, m of the comet, divided by the distance between them. And so this is going to mean that our potential energy is proportional to 1 over the distance between the comet and the sun. And so you can see that we plotted this just like this. The pink line is our potential energy. So now that we have that done, we're going to define our limits. And we know since the comet starts out very far away, we can define R max to be basically infinity. However, there is an R min, which occurs right where the maximum potential between the comet and the sun happens. And so we're just going to pick an arbitrary point. We don't have enough information, but an arbitrary point for our R min. So now we're ready for our third step, which is going to be determine K at each of the limits. So first let's look at the limit where R is infinity. Now we know that when it's that far away, the potential energy is essentially 0. However, the comet still has some sort of kinetic energy because it's moving towards the sun. And so we have to set the kinetic energy at R max greater than 0. And then we know that it's going to increase exponentially because velocity squared as it gets closer. And then R min is going to be the maximum velocity. So we can go ahead and stop there. And then our final step is just to draw in E total. And this is the easiest because we know that E total is just K plus U. And so we can see here that if we add this positive K with the negative U, it gives us this positive total energy, or the blue line, E. I hope this helped, and it sure helped me going back and reviewing the problem. Thanks.